Good morning, class. I'm Mr. David Ayoro, a teacher of chemistry. We are still on acid, bases, and salts. And in our last lesson, we discussed how the cations can be identified from a solution, and we said that we use two solutions. That's ammonia solution and sodium hydroxide solution or potassium hydroxide solution. So in our last lesson, we discussed how you can use ammonia to identify positively charged ions. Today, we want to discuss how sodium hydroxide or potassium hydroxide can be used to identify a solution which is containing cations, that is positively charged ion. And we also said that the best way of identifying these cations is by use of a precipitate, that is precipitation reaction. And we said, what's a precipitate? We said a precipitate is any insoluble solid that separates out from a solution during a chemical reaction. So you can be given a solution in the laboratory and you are given sodium hydroxide and you are asked to identify the cation which is in that solution. So the procedure will be given. You add 3 to 4 drops of sodium hydroxide to the solution being tested. You observe any change, then you add excess and also observe any change. Then you write the observation and the inference, that is the possible ion. So these are samples of the observation which will be gotten from a reaction, from a procedure like this. So the first one, if you get a white precipitate, then the precipitate does not dissolve. The precipitate is solid with excess. Precipitate is solid with excess, forming a colorless solution. Solid with excess, forming colorless solution. Then you infer either zinc, aluminum, or lead. Why are they forming white precipitate? And how come that the precipitate is soluble in excess? So let us look at zinc. If the solution being tested was containing zinc, so zinc reacts with hydroxide ion of sodium hydroxide, forming zinc hydroxide. So zinc hydroxide is white precipitate. Then if you add excess, then the white precipitate will react with the excess of hydroxide, forming a complex salt. So the complex salt is what we call tetrahydroxo zinc 2 ion, which is a colorless solution. And it is an anion. You know, in our previous lesson, we talked about a cation being formed with excess ammonia. But in this one, it is tetrahydroxo. Look at the formula for tetrahydroxo. It's a cation which is negatively charged with the 2 ions, with a negative ion of 2. So let us compare this ion with the ion. If it is ammonia, the white precipitate will dissolve also, but in this case, it dissolves because of the formation of tetraamine zinc 2 ion. And look at the tetraamine with ammonia, it's ammonia. It is a cation. That one is an anion. So this one is tetraamine zinc 2 ion with excess ammonia. And this one is tetrahydroxo zinc 2 ion with excess sodium hydroxide. With lead 2 hydroxide the same. It forms, with lead 2 ion, it forms lead 2 hydroxide, which is a white precipitate. The white precipitate dissolves. This is the ionic equation for the dissolving. This is a white precipitate formed with a few drops. With excess, it forms colorless solution, which is called tetrahydroxo lead 2 ion, which is also anion with a negative charge of 2. That's negative charge of 2. Then with with lead. With aluminum, it forms a white precipitate because of formation of aluminum hydroxide. The aluminum hydroxide dissolves in excess. This is excess sodium hydroxide, forming also a colorless solution, which is a complex salt called tetrahydroxoaluminium ion. And this one, look at the formula, having a negative charge of 1. And this is the formula for tetrahydroxoaluminium ion. Then, if you get a wet precipitate which is insoluble in excess, then you infer the ions of alkaline earth metal, that is calcium or magnesium. The reason why it is insoluble in excess is because this magnesium hydroxide formed is not soluble in excess sodium hydroxide. If you get no wet precipitate formed, then you infer potassium ion, lithium ion, or ammonium ion when you use sodium hydroxide. But if you use potassium hydroxide, then instead of inferring potassium ion, you infer sodium ion, because potassium ion is already in the frame of the equation. So it is either potassium ion, lithium ion, or ammonium ion. This is because the hydroxides, look at the ionic equation, the hydroxides are soluble. The hydroxides are soluble. That's the reason why you will not observe any, you'll find that there is no white precipitate formed. No white precipitate formed. If you observe a blue precipitate, the precipitate is insoluble in excess, then you infer copper 2 ion. Copper 2 ion is the one having blue precipitate, and it's a blue precipitate because of the formation of copper 2 hydroxide. This is a blue precipitate copper 2 hydroxide. But with ammonia, hope that you remember, with ammonia, the blue precipitate dissolves to form tetraamine copper 2 ion. This is a complex salt formed with excess ammonia. But with sodium hydroxide, it does not form a complex salt. So the precipitate is insoluble. So if you get a green precipitate which is insoluble in excess, then the possible ion there must have been iron 2. Green precipitate iron 2 because of formation of iron 2 hydroxide, and the precipitate does not dissolve because there is no complex ion formed. Look at the ionic equation. This is the test solution plus the hydroxide formed, plus the hydroxide from sodium hydroxide, forming iron 2 hydroxide, which is a green precipitate. This precipitate is insoluble because it does not form a complex salt. The precipitate is only soluble if a complex salt is formed. But because there is no complex salt formed here, the precipitate is insoluble. Look at the brown precipitate. If you get brown precipitate, which is insoluble in excess, then you infer iron 3 ion. The iron 3 ion is formed because of the formation of iron 3 hydroxide. Look at the ionic equation. Iron 3 ion reacting with hydroxide ion, forming iron 3 hydroxide. Which is a brown precipitate. So the precipitate will not dissolve if there is no complex salt formed. But the precipitate dissolves if a complex ion is formed. So that is how you use sodium hydroxide to identify the cation. Thank you. Let us meet in the next lesson.